about how we secure Erlang systems.
Yeah, thank you. So, before we start, I would like to read you off a quote from Joe Armstrong. It's a publication, History of Erlang, from 2007. So, our idea was to connect stock hardware through TCP IP sockets and run a cluster of machines behind a corporate firewall. We were not interested in security since we imagined all our computers running on a private network with no external access. This architecture led to a form of all or nothing security that makes distributed Erlang suitable for programming clustered application running on a private network, but unsuitable for running distributed applications where various degrees of trust are involved. So, my question. Do we use Erlang today like this? I don't think so. So, my name is Victoria, he is Alex, and we work for Klarna. Klarna is a bank, so security is utmost important. And personally, we are really tired of excuses why we don't care about Erlang security. So, with this talk, I would like to convince you to join us and challenge the status quo. It's not okay that today an Erlang system is secure if and only if human experts did no mistake. And so security is not granted and Erlang is not your friend. And we have challenges in 3 levels. Erlang OTP level challenges, development challenges, and operation related challenges. Alex will show you how an example about Erlang OTP level.
So regarding Erlang OTP level, we would like to talk to you about the possibility of doing a denial of service attack by using the way the handshake of the Erlang distribution protocol is implemented. But before doing that, I'm going to refresh your memory about how the Erlang distribution protocol handshake works. So imagine that we have node A and a node B. So let's assume that B is the node that is accepting connections and A is the initiator. So this starts by establishing a TCP connection, and then the second step, the node A, the initiator, sends its node name. And then in reply, the node B sends a status message saying, among other things, if the node is allowed to connect. And then B starts the authentication part of the handshake protocol. Well, but we can stop here, because at that moment when that node name is sent to the node B interprets that node name, does some checks, and one of the things that is in that code is a list to atom. And so, yeah, so you may know where this is going, right? So the assumption of this attack is that, okay, not copyright. No, okay.
Somebody's doing a denial of service.
Yeah, someone's saying, yeah, it's already started. Match just work. Okay. Can I please have one slide? Okay, cool. So the assumption for assembling this attack, is that the attacker needs to know the port of the distribution protocol, that it's not that hard. With port scanning, it's possible. And then the attacker needs to be able to reach that port. Okay, that may be a little bit harder, but let's assume that that's possible. So then, what does the attacker needs to do? Okay, I guess you already figured it out. It needs to do this n times until there's you reach the system limit of the atoms of the node will go down. So, okay, the node B is then the victim, and then the node A is the attacker. Okay, so how long does this take? So in my laptop it took 17 minutes, and I recorded the video with this. That's what I would like to show you. Yes. So, I started here a node with a cookie that the attacker doesn't know. This is important. And then I will put here, I will count every 20 seconds the number of atoms. And I will just taking the port, and I have a separate application that is implemented in Erlang that doesn't need to be implemented in Erlang. Separate application that will spawn 2 workers and will start to do exactly what I described previously. I counted the timer there, and yeah, I started here. And I'm printing here every 10,000 different names that are generated. I'm printing like the name that was generated there. And I will fast forward this, but you can see already that the atom number on this freshly created node was 8,500, and now it's 20,000. And if I start fast forwarding this, then we will see that 17 minutes later, boom, system limit reached. So this node goes down. Yeah, so we'll go back to my slides to now tell you. Okay, it's interesting that interesting and scary that it's possible to do this, but I'm more interested in telling you about techniques on how to prevent this, because it's possible. So first thing, ensure you have 2 options basically as far as we know. The first thing is ensure that the Erlang distribution port is only available to trusted nodes. And then the second thing, there's a function that can be used in runtime, so you can do it already in your running systems, that is net kernel allow, and you can specify either a list of host names that are allowed or a list of node names. A list of host names doesn't work, because with the same host name you can generate an infinite amount of nodes, node names, but if you put a finite set of node names, then you should be okay. And I will hand over to Victoria to talk about more techniques.
Yeah, thank you. So Alex showed an example about Erlang OTP level security related issues. But so I said we have 3 challenges, right? So we have development and operational challenges. So let's start first with the development one. Erlang is a very good friend when it comes to reusing existing software components, right? I just specify it in my rebar file, and then I can immediately use that application. But have you reviewed that code? Do you know what that code does? Is that code from a trusted vendor? Do you see that it has history? Have you cloned that repository and put it under your own control so then nobody can change the code? So when you do the review, please, if you find issues, report. Then another thing that you should take in mind is sometimes it's very hard to deliver software with the most secure configuration enabled by default. So maybe it's a good advice to look into the configuration options and change them to give you the most security. So an example is the SSL library. It doesn't do certificate checks by default, so you may change that. Now, if you are done with the dependencies, look into your own code. Identify the user-facing interfaces. Maybe it's a REST API, maybe it's something different. And then look into where do you accept data from the outside world. Do you do any validation on it? Do you do filtering? If no, then I strongly suggest that you follow the flow of the data. Because if you reach a point where you run an OS command, then this is a true flash injection, right? There we go. Then if you reach an any2 atom call, then somebody can burn your VM by hitting some system limits. So, operation. So look into your deployment. First on the host level, try to lock down the machine. Try to remove any programs that can interfere with your running VM. Then check the firewalls, use IP tables, secure your host. Then look into the OS user that runs your VM. So if somebody can have access to your Erlang code, then it can run any OS command on your host. And then the only thing that will prevent deleting all your data from that host is the fact that the user that runs the VM has limited rights. And yeah, so everybody knows that React is shipped with the cookie React. Maybe you want to change that? Good. So now we are all done, but do you have logs? Do you have visibility of what you are doing there? Are you logging any shell commands that somebody runs on the VM? Are you logging bash commands that somebody runs there? Do you have metrics? Do you know how many requests arrives to your node? Maybe you want to collect them and visualize them. With real-time monitoring, you can detect bad trends. If you combine machine learning there, then maybe you will detect them even earlier. And maybe you can react to them. And when you are done, that's great. But then next, schedule the new investigation when you go through again of your system. Because security is not a one-time task. It should be a repeated process. So what we would like to point out is that this is a great opportunity to researchers and companies active in R&D, because this is like a new area of research, and you may want to kickstart your project now. And to the Erlang community, developers, operators, you want to review your Erlang system, you want to review your deployment. Thank you.
Question. So, do you know of any tools which help this process?
So for the development part, there is the PAST tool. It's called PAST. But so it scans your code and points out all calls towards OS command or like list to atoms. The problem with that is that you know where you call those commands, but you don't see which data goes into that. So I would be more interested in a tool, if I can which will do the analysis that I suggested. So it finds first the references to those function calls, and then go back using data flow analysis, control flow analysis, and then shrink down the result to the entry points, which are the northbound interfaces.
How about using quick check for penetration testing?
Good idea.
Just say, this is what safety means. Quick check. Is this right? Maybe.
No, start doing that. Yeah.
Have you done the intrusion detection for Erlang systems?
Have you done?
Intrusion detection, like do you do real-time monitoring and look for bad signs?
Yeah, you seem to do.
Yes. Currently have a team that does that with the logs. They analyze it. But they don't use Erlang tools for that, but they have different set of tools to do that.
I have a question. So typically with monitoring, right, one of the main stumbling blocks is the additional overheads, right?
Yes.
So from your experience, Clark, right, what would be an acceptable level of overhead, right?
As minimal as possible?
Yeah, fine. But it will happen, right? So people usually throw like 10%, 18% usually.
Oh, I think that's
Just call it.
yeah. But you know, if you collect metrics and logs using the push model and not the pull, then you will have less effect on the host. Right, definitely.
Our experience was, I mean, we've done some model modeling. There's overhead quickly explodes. Maybe it's the kind of overhead that's supposed to.
What would you like to see from the OTP team or for outside people to build in? Like, what would the extra gear, like one of the things off of code, I was thinking about the code server, at least the code loader, and about, you know, that'd be an interesting thing if you were to keep additional modules from being loaded in, so you couldn't just do NL and drop a bunch of attacks on that. But I'm curious, like what kind of things would you like to be able to check and guard and put padlocks on that are just part of, OTP? Like what are the, I guess, what's your wish list?
Well, I would like for it to be super easy to do the right thing. I would like, okay, I'm starting this Erlang project, and I don't need to worry about changing the configurations to have like certificate validation, or I don't need to worry about finding in the documentation or not about this or this function net kernel allow and all that. I would like it to be super easy. So I would like to be secure by default, instead of having this approach. But I understand how Erlang was built, right? I would like that to change, if that would be possible, because the applications that we have nowadays, they are different to have when Erlang was built.
I would as well like to have user groups, so I could give permissions to processes.
Like an ACL kind of thing off inside of within the.
So taint tracking is a way of keeping track of where inputs have flown to. Taint propagation. It would be interesting to be able to do that in Erlang, wouldn't it? Maybe there's a parse transform that could do it to some extent. Have you thought about doing that? I mean, one problem is that if you have a tainted value, you pass it to code that's not being compiled with a parse transform. You might go to it is.
That's very good.
I just want to add to the list of things that I would like to see in Erlang. And it's some kind of proper sandboxing. So for example, if I have a process that handles REST API requests, that process should be run in a sandbox that, for example, cannot access the file system. The best option I can do at the moment is that I spawn the process on a node that runs on the restricted user or something. But even that would be a very leaky abstraction, because if I connect the nodes via Erlang distribution protocol, then it would come back to my more powerful node with an RPC call, and that's through permissions. For example, this is totally missing from Erlang.
So do you think, like, when you spawn a process, you should be able to spawn it with capabilities to say this can have access to the file system, or this can spawn other processes?
So you can just access this temporary direct CAG there, or under it, or found in a node that cannot do an RPC back to the parent, or something like that.
So it seems like, so this stuff is erratum, right? Maybe we can rename this.
Is that tag still in the distribution protocol?
Yeah, it's so it's just it's a consequence of how Erlang deals with node names. So it needs to be converted. So it's a type that was selected by all that code is an atom. So it needs to be converted at some point. And the best that was done was to have this validation if the node is allowed or not. So I don't think that this is something that.
But
Do you think it should be fixed?
So
Do you think there should be
wait.
a solution?
So Erlang 21 came out, and that has a small fix. Okay, this is again that. But So if you use net kernel alone, then it will do the conversion now after the node is allowed. So the net kernel allow will run on the binary version of the node name. But before Erlang 21, even if you use net kernel allow, you are still in risk. So you want to upgrade maybe.
Wouldn't it make sense for Erlang to garbage collect assets?
Yeah. Wonderful.
This could be a limited case. There's a hack in the VM for doing the selective receive for gen server results, where there's a reference created that's sent that you know that the scope of that reference is limited to a particular section of code, and there's a virtual machine hack to optimize the mailbox processing in a very limited case. Well, this would be, in theory, a very limited case of the system can tell you, well, the system knows if it actually did create a new atom when it did the list atom, but it was created in this scope, so maybe you could say, in this particular case, it would be safe to delete it, because I'm the one who created it, and I created it recently enough, I didn't give it to anyone else. Maybe.
Okay. I think some of us are hungry. I think we should go. Thank you very much.